In this video, we're once again looking at polar coordinate system. In terms of the polar coordinate system, sketching a graph, you're still going to want to create the x and y coordinate table. However, you're going to do this with r and with theta. Now, the difference between this system and the previous system is that normally we do x comma y, and our x is our dependent variable, our y is our x is our independent variable. We pick the x values to plug in, and our y is our independent variable. Those are the values that we get back. Well, in most cases, our formulas will be f of theta equals 2, which means that we're going to want our r to be our independent variable. Okay. Now, even though mostly we have an x comma y versus a r comma theta, again, this is slightly backwards because normally it's independent dependent, and we've swapped it now so that it's independent dependent. So what we're going to do is we're going to pick theta values and we're going to get back r values. This is the normal general way of how we're going to set up a table of values to plug in. But you'll notice that this first graph asks us to graph theta equals 3 pi over 4. Well, that means that this is going to be the case where I have 3 pi over 4 for every single angle measure, but my radius measure is, say, 0, 1, 2, -1, -2, so on and so forth, any possible radius measure. So if I can pick any possible radius measure where I'm at 3 pi over 4, so 1, 2, 3, there's 3 pi over 4, I can pick any radius measure that's sitting on that line. So whenever I have theta equals to a number, this is actually going to be a linear equation passing through the origin. And that's the important part, is that this is going to be, in the polar coordinate system, a linear equation passing through the origin. The second graph is r equals 4. Well, for r equals 4, what we're looking at is a function where the radius is always 4. Well, again, this should make logical sense that I'm going to go out 1, 2, 3, 4, but I can go out 1, 2, 3, 4 in any direction and any angle measure, which means that this is nothing more than the equation of a circle in polar coordinate systems. Okay, so this here is a circle centered at the origin, where this one up here is a line passing through the origin. Those are the two basic equations in polar coordinate systems. We'll be looking at more of those later on.